Okay, good morning, differential equation students. As promised, we're going to get into what are called separable differential equations today. This is in Chapter 2, Section 1, 2.1. Okay, and so a lot of interesting differential equations are of this form, which makes them important to study. And they're also somewhat easy to solve compared to other ones, possible to solve, which makes them interesting to study. So, a separable differential equation is one in which you have the derivative here. You can either write it as y prime or dy dt, either one. I'm going to write it as dy dt just to make it explicit that the independent variable is t and the dependent variable is y. So there's your dy dt. And then you're able to use some algebra in order to get this differential equation in the form where everything over on this side, together with the derivative, just has y's in it. Okay, it could be a sine of y, it could be 1 over sine of y, it could be e to the y squared, it could be 1 over y cubed. Okay, just y's. Whatever they are, they're just y's in it. No t's at all. Okay. Similarly, over here, all you have are t's. So t squared, sine of t, whatever you want, but all the t's. And so that's why we call it separable, because you've separated the variables. You've got the dependent variable y over here and the independent variable t over here. So, if you can get it into that form, then here's how you can go about solving it, okay? What you do is you just take the antiderivative of both sides, okay? So here we go. We're going to write this as h of y dy dt, and we differentiate that with respect to t, and then the same thing over here, g of t dt. So we take the antiderivative of that with respect to t. And if we do that, then we can make a substitution over here. Okay, remember how to make a substitution from Calc 1? What we're going to do is we're going to let u be equal to y of t, and so du is equal to the derivative of this, which is going to be dy dt times dt. That's how you make your substitution. You're right. Again, I'm not sure who you've had for calculus, so you might have first done it this way. You take the derivative of this and get du dt is equal to dy dt, and then you bring the dt over like this, and you get your substitution. So there's your substitution. So now you can write this as h of u, and then all of this here becomes your du, and that's going to be the antiderivative of this. And then this is just a dummy variable, so it doesn't matter whether that's a u or a y or whatever it is. So the point is, you get the answer by just taking the antiderivative of both sides. And when you take the antiderivative, I'll just say find antiderivative of both sides and when you do that, this is just a dummy variable, so it doesn't matter whether that's a u or a y or whatever it is. So if you want to, you can write this as h of y dy here is equal to the antiderivative of g of t dt here, and here you're going to have some function of y, and here you're going to have some function of t, and you go from there. So I don't want to go any farther because basically it's the examples that show how to use this. So that's the idea. You just take the antiderivative of both sides and you get the answer. So let's do an example. There's several of them that I have you do in the textbook, And let's go ahead and do, let's do the second one together. Let's take the middle one and just see once how we can do it. So it says solve the differential equation y times x plus 1 times dy dx. Notice here I've got the independent variable as x, so we'll switch around, either use x or t depending on preference, is equal to x times y squared plus 1. Okay, so let's look at it. First of all, notice that it is a differential equation because it's an equation which involves y with some of its derivative, a derivative of y together with other things. So it's a differential equation. Secondly, notice that it's a first order differential equation, right? Because the highest derivative is just this one right here to the first power. So it's first order. Is it a linear differential equation? Do you have the answer? The answer should be no, because to be linear means that the derivative and y is only, you don't do anything with y or its derivatives. Here, notice I squared it. So the fact that I squared it there is what's keeping it from being linear. If that were y to the first power, it would be linear, but it's not. Well, actually, it's not also, because if I were to solve this thing for dy dx, I guess I would get a y in the basement here, so it wouldn't be for that reason either. The fact that if you write dy dx and you solve it for that, you're going to end up with both a y squared and also divided by y. It's not linear. So a couple reasons why it's not linear. Okay, so that's all well and good. The point is it separable? So to be separable, we have to be able to get all the y's on one side and all the x's on the other. So this we can do, right? We can divide both sides by y squared plus 1, and we can also divide both sides by x plus 1. So we're going to get y over y squared plus 1 times dy dx is equal to x divided by x plus 1. Agreed? Bring this over and divide both sides by that. And then, in what we just saw, what you can formally do is to just bring the dx over here, and you're going to get y times y squared, or divided by y squared plus 1 dy is equal to x over x plus 1 times dx. And so there, it's separable. It's already shown to be separable here, but this is the next step. Now you can write it like that, and now just as I showed you a minute ago, we can go ahead and just take the antiderivative of both sides. So there you are. Now we have to take the antiderivative of both sides. How do we do that? So let's go ahead and put in our antiderivative, our integral sign. And how do you go about doing that? So this relies on your Calc 1, okay? This might mean that you need to go back to your Calc 1 book and do some digging to get some help or whatever you want to use, something from the web or whatever in order to get some help on it, okay? But let me help you on this one. So here's some things that you learn in Calc 1. First of all, what you learn is that you can do a substitution. So let's go ahead over here, bring this over here, and I'm just going to leave this as is for the moment. We're just going to work on the left-hand side. Okay, so we're just going to work on the left-hand side over here. And find its antiderivative. And the way to do it is to realize that you have the derivative of the bottom is up on the top. So you can make a substitution again. You can let u be equal to y squared plus 1, and then du becomes the derivative of this, which is 2y, and then you tack on the dy like that. And so this becomes what? The bottom is going to be u. Notice that the top is y dy. And notice that y dy is equal to 1/2 du. So the half you can bring out in front of the integral sign. There's your 1/2, and there's your du right there. Okay? Stop it, stop the video, and take time to check everything out. Make sure you understand each of these steps. Okay? And now, remember that the antiderivative of this, you can either write it like that, or if you want to, you can write it as 1/u du. Either way works. The antiderivative of 1/u is the ln of u. So this is 1/2 the ln, actually, of the absolute value of u, plus c. And then finally, you can substitute back in for u and get 1/2 the ln of y squared plus 1 plus c. So there it is by substitution. So all this can go in right there. So this is going to be 1/2 the ln of the absolute value of y squared plus 1. And I'll leave off the plus c because we're going to have a constant on both sides. Well, I might as well throw it on here. Plus c. Just to show you. Okay, so there's that side. Now I'll erase this. We don't have too much room here, so I'm going to have to erase it as we go. And let's find the antiderivative of the right-hand side. Okay, this looks, whoops, let's see, this is a case where I got a little glare right in the wrong spot. Let's see, I guess, well, no, that's fine. Okay, this is ln of absolute value of y squared plus 1. So, yeah, nothing can do about that, unfortunately. Let's see, that comes, let me turn off the light here. No, that comes from the window. Okay, so there's going to be that couple little spots on the board where you've got a little glare there, but that's ln of y squared plus 1. So what about this one right here? How do we go about finding the antiderivative of that? It looks easier than this one. See that? But in fact, it's harder. This one was easy because the derivative of the bottom was up on top. But here, that's not the case. The derivative of the bottom is just 1, but we've got an x up there. So how do we handle that? So several ways. One way is to make a substitution again. Let's just give it a try. Let's just see what happens. Let's let u be equal to x plus 1 and just see once what happens. That's the thing about integration, finding antiderivatives, is that you don't always know if it's going to work or not. You just got to give it a try and see. So if u is equal to x plus 1, then du is going to be dx. Agreed? That's just going to be dx. So now we've got u on the bottom. Agreed? There's your u. Dx just becomes du, so that's right there. But now, in order to finish this problem, I have to get all the x's turned into u's. And here I just have an x, and I have to somehow get that turned into a u. Well, how do I do that? Well, I can do that because x is equal to u minus 1. See that? X is equal to u minus 1. So I have that right there. Now that is much easier to integrate than this one, for hopefully a simple reason to you. If you have a fraction a plus b divided by c, you can write that as a over c plus b over c. Agreed? You can break up a numerator. On the other hand, if you have a over b plus c, that is not equal to a over b plus a over c. You can't break up a denominator, okay? So the fact that I've written it like this now allows me to break this up into two fractions. I'm just going to get u over u minus 1 over u du. And of course, u over u is just 1. 1 minus 1 over u du. And now I can take the antiderivative. The antiderivative of 1 is just u, and the antiderivative of 1 over u is, as before, the ln of the absolute value of u plus c. So you've got that right there. And finally, I can substitute back in for x again. U is equal to x plus 1. So this is going to be what? X plus 1 minus the ln of the absolute value of x plus 1 plus c. So all that goes over here. I'll call this C1 and I'll call this C2. They're just different constants. So that's going to be x plus 1 minus the ln of the absolute value of x plus 1 plus C2, like that. So there you go. And let me put a line in here to separate those two things. And now you can solve it for y. How do you solve this for y? First of all, let's just notice that the difference between two constants is itself a constant. So let me just get rid of this one and let me just call this c. C is just equal to C2 minus C1, but it's just going to be a constant. We're going to find that constant once we have some information about the problem anyway, so it doesn't, might as well make it as simple as you can, just call it a C. So there you have that. Now, you can multiply everything through by 2. And if you multiply everything through by 2, you're going to get the ln of y squared plus 1, the absolute value of that, is equal to 2x plus 2 minus 2 ln of x plus 1, parentheses, plus 2c. Okay? But notice that this is just equal to 2x minus 2 ln of the absolute value of x plus 1. And then 2 is a constant, and 2c is a constant, so you add those things together and you just get a constant again. So again, if I wanted to, I could call this a C1 again and call this a C1. And if you add all those together, you're just going to get a C. So the point is, by the time you're done with all that, you get yourself a C again. And so now, how do we go from there? Now you want to solve it for y. So you take e to both sides. And when you do that, you're going to get y squared plus 1 right there is equal to, I'm going to again use some of the things that I taught you in the last lesson. I'm going to write this as e to the 2c times e to the minus 2 ln of x plus 1 times e to the c. Okay, again, I'm going to have to use up some board space here. And what's that equal to? So I'm going to get y squared plus 1 is equal to, first of all, e to the c, oops, I'm sorry, I need an absolute value there. So there I still need absolute value. So I'm going to get e to the c here, put that out in front. And I'm going to get e to the 2x right there. And now I'm going to write this as e to the ln of absolute value of x plus 1 all to the negative 2 power. you have a -2 out front, again, what I did on the board last time, the previous lesson, you can bring this -2 up here and you can write it like this. And so what happens there now? I'm going to get a y squared plus 1 right there is equal to e to the c, e to the 2x. And now e and ln, they undo each other. So e to the ln of anything is they just undo each other. So this is just going to be times x plus 1 absolute value to the -2 power. So what do we get? We're going to get e to the c times e to the 2x, and then this can go downstairs and write it as x plus 1 quantity squared, like that. Okay, we're almost done. Now you can get rid of the absolute value. Remember, if the absolute value of x is equal to 4, that means that x is either equal to plus or minus 4. Agreed? Let me make sure this thing is still working. Sorry. Try it again. There we go. Yep, still working. Okay. So I can get rid of this absolute value and write it as y squared plus 1 is equal to plus or minus e to the c times e to the 2x, all divided by the absolute value of x plus 1 quantity squared. Now, notice that e to the c is itself, again, just some constant. It's a positive constant because e to anything is always positive. But this, by the time you either put a plus or a minus there, this could end up either being positive or negative. So that's just going to be some constant. It could be any constant. So let's just call it a. Doesn't matter. We can call it c again, but we've used c for all those. Let's call it a. A e to the 2x rather, divided by absolute value of x plus 1 quantity squared. And finally, how do we finish this? Notice that we have to subtract 1 from both sides, and then we take the square root. So if I subtract 1 from both sides, we're going to get a e to the 2x all over the absolute value of x plus 1 quantity squared. Now subtract 1 from both sides. Now we're going to take the square root. And there you have, plus or minus there, your final solution. So I wanted to do this one with you because it's pretty involved, and you're responsible for handing it in, writing it up if asked to. But here I've given you some help on it, and it just shows that there's lots of steps involved. Notice that those steps involve knowing Calc 1 and knowing algebra, knowing the properties of exponentials and logarithms. Okay, this is where everything comes home to roost. You have to know all this material, know when to use it and how to use it. So there's that problem for you. Okay, that's problem number 2.1.2. Okay, and then if we had some sort of initial condition, if we were told that y of 0 is equal to 10, then we could put a 0 in here for x, and we'd figure out what a would have to be in order to give us the right value. Okay. In fact, let's just go ahead. No, I won't do anything more than what I ask in here. Okay, very good. Let's just get started on a couple of those other ones that are in this section. These are more involved problems than you'll typically see in this course, but again, it just shows you the kinds of things that you can do with differential equations. What about the next one here? 2.1.3. Let's get started on it. It's x plus 1 it's going to be x plus 1 times dy dx is equal to x times y squared plus 1. Okay, so that's what we have. So, can you do it? Let's get started on it. You want to get all the y's on this side and all the x's on this side. So we're going to get 1 over y squared plus 1, and might as well just leave the dy right there. And then all the x's on this side. So we're going to have x divided by x plus 1. And then you bring the dx over, and there you've got it. You've separated the variables. Okay? So notice this looks similar to the previous problem, so I won't do anything there. What's the antiderivative of this? Okay, do you remember what that one is? Again, this goes back to Calc 1. You need to remember that the antiderivative of that is equal to the arctan. Okay, because the arctangent of the derivative of the arctangent is that right there. So that's a little bit of a hint on that one. Okay, very good. So that's section 2.1, which is just getting practice solving separable differential equations. We'll stop right there.